Hey guys, Dr. McDonald again. Time to start on Chapter 5, the Integumentary System, more commonly known as skin. Okay. Ooh, I'm in the way again. Integument is just something, it's something that covers something else, a layer, envelope. We have in our integument, or our skin, we'll just use that term, 3 parts. Now we've got the epidermis, which is going to be epithelial cells. We've talked about the tissue. We've got the dermis, which has 2 types of connective tissue. The one closest to the epidermis is a relar, and the one underneath it is that dense irregular. Underneath that, we've really got, this is not really part of the skin, which just to be complete, is the hypodermis. I'm sure most folks have heard of the term hypodermic needle, so it goes with it. Superficial fascia is another name for it. The deepest region, this is also the subcutaneous, which means under the skin. A lot of times we give injections, and if you see an SQ, that's the abbreviation for subcutaneous, and we'll often refer to it as sub-Q. This is mostly going to be adipose tissue. It's kind of a region that cushions and insulates our body from the outside world. Okay, guys, this is really interesting. These are the cleavage lines. What happens is in the skin, there's an overall pattern of how the skin is actually formed. And these red lines you see are that pattern. That's important for the surgeons because when they actually make an incision, they need to make it along those cleavage lines because then the skin is easier to approximate or bring together so that you can suture it up and not leave scars. On the torso, well, the thorax predominantly, it's mainly going to be parallel. Real easy, the T4 and the T10 is going to be right there at the umbilicus. But we'll get to that later. But in any case, you don't really have to know anything except that they exist and that any incisions parallel to those are going to be easier to close up. Okay, the function of the skin. Well, it's a chemical barrier. We have a relatively low pH on the outside of our skin, and that acidity helps to keep some of the bacteria off of us. We also make antibacterial proteins, kind of like almost like a natural antibiotic called defensins. So this is called the acid mantle of the skin, and there's other things going on too that help to defer it. We also have a very salty skin, and a lot of bacteria cannot exist in that salt. It'll just suck the water out of them. Now there's some species, especially Staphylococcus, can live on that salt concentration. It's much saltier on our skin than it is in our body and our fluid. This guy is also a barrier to protect the organs underneath. And this is the important part, guys. There are, let's see, the keratin, which is a protein that is inside these flattened cells right here, is kind of waterproof, and we also have a waxy substance between those lamellar granules. I guess you can see it right there, and those make our skin waterproof, which, I mean, it's not absolute. You spend 2 weeks in water and your skin's going to come off, but for most normal purposes, for taking a shower or going for a swim, we keep all that pure water or water that has a different osmolarity out of our system. Also, it keeps us from dehydrating, from losing water. We have problems if we dehydrate. But again, just like in every case, we talked about anything that's lipid soluble doesn't have such a hard time getting in. Oleoresin is the substance produced by poison ivy that can get in there and cause lots of problems. Some organic solvents, some salts, some drugs can be absorbed through the skin. But for the most part, it's a really good protection system. Now, melanin is a pigment. In other words, it has a color. That color is brown. So melanin in people from European ancestry, if they go out in the sun, they will tan. Their skin will turn a brown color because those melanin granules are there to protect the dividing cells from that radiation, which can cause skin cancers. We'll talk about that for the end of the PowerPoint, but this is kind of our situation. We're going to talk way more in detail. It's just an intro, guys. Biological barriers. If our skin gets scraped and even a micro abrasion, a bacteria does not need a big doorway to get inside. We have cells in there that are always on guard. Those dendritic cells right there. Also the macrophages and all the rest of these guys only come in as needed, like the neutrophils. These are our white blood cells that are out there to protect us from the bad guys. There's those antimicrobial membranes. They're Staph aureus growing on our skin. Again, it's very possible for those guys to live in the salt. But the dendritic cells especially, they are going to monitor for any kind of bad guys coming in. If there's a bad guy, the dendritic cell is going to gobble them up, kill them, and cut them into pieces and go show the pieces to the lymph nodes, to these guys, the B and the T cells. Don't worry too much about that. That's an AMP2 topic. Body temperature regulation. We mainly dump heat through our skin. Now, a lot of animals can't do that. Pigs can do it, but dogs can't. So that's when dogs are panting. They're blowing out hot air, and of course they're drooling because they're trying to dump heat because the inside of their body temperature has gone up too high. You and I sweat. Now, we sweat about a half a liter every day. It doesn't beat up on your skin because, you know, the air is pretty dry. Heated or air conditioning has pretty dry air, so it just sucks it up. When we are outside in the middle of the summer and we're working hard and we're building up heat so fast that and if the humidity is high, the air is having a hard time absorbing it, then the sweat beads will beat up on your skin. But what we do is we open up some of the blood vessels in the areolar tissue, and that heat gets absorbed, and the sweat glands, aka, well, there's two of them. There's the eccrine and the apocrine. We'll talk about those later, but basically they're just going to, the eccrine especially, they're going to have this little tube that goes to the surface, and that's where your skin pores are at. That's for beads of sweat, which is mostly water. And we talked about the high heat of vaporization of water, how water takes a lot of heat to change from a liquid to a gas, like water vapor, not just steam, but water vapor. Cutaneous sensation. We have sensors on our skin that detect hot and cold and pressure and vibration, and we have pain receptors, and we have receptors on the hairs on our bodies so that if any little mosquitoes touch it, we are immediately alerted so we can get it before it gives us a disease of any kind. Looking on here, guys, there's that root hair plexus. When the hair is moved, you get a signal. Some of these guys, the deeper they are, like this Pacinian, that's deep pressure. The more shallow, like the Meissner's, right there at the junction between the epidermis and the dermis, would be more for light pressure. And then some of those pressure sensors also work with vibration. What does the skin do for us metabolically? It makes vitamin D. It's going to make vitamin D, the precursor, the starting product, after 20 minutes of sunlight exposure. That's all it takes. Make some collagenase too, enzyme to break collagen. Also, some of the skin can convert some of our carcinogens and hormones and render the carcinogens harmless and activate the hormones. 5% of the body's blood supply is in the vessels in the skin at any given time. And again, we can squeeze the blood. I'm trying to get this right onto. We can squeeze the blood vessels or open them up depending on the need. If it's really hot, we're going to open up those blood vessels because we want a lot of hot blood to flow through there and that heat radiate up toward the sweat gland so we can dump it. If it's cold out like it is in the winter time, then we keep them kind of closed. And that's also why your extremities get cold. When it's cold outside, you are deliberately shunting the heat away from those areas because otherwise they'll suck the heat out of your core and then you'll really be in trouble. Excretion, yes, we have nitrogenous waste. We do get rid of some urea in our sweat, and there's some salt. 99% of it is going to be just water, but there are products. Okay, we already talked about the structure, and I'm not going to go over that again, but now we can look at a picture. Now this tan colored part right here is the epidermis. And if you see, you can see how they got these squiggly lines. And so the epidermis and the dermis both have these and they fit together. They call it interdigitate. The dermal papillae are the ones, of course, on the dermis and the papilla. Now, there's the epidermis and there's sublayers on it. We'll get to that. The dermis we've already talked about. We've got two layers. We've got the papillary layer next to the papilla. That's the areolar tissue. It's about 20% of the dermis. The reticular layer is 80% of the dermis, and it is dense irregular connective tissue. That's the part that we actually turn into leather from animal skins because dense irregular tissue is tough. It's hard to make it's just protective for folks who use it for protection. Down below the dermis, you see the adipose cells, adipocytes, and again, that's the hypodermis. Okay, so here's the hair, the shaft. Now, right there, those guys that look kind of like clusters of grapes, those are called sebaceous glands. Those are the oil glands. We produce an oil, which again has antibacterial products in it, but its main job is to cover our skin and keep it from being dry and cracking, because if your skin cracks, then you're opening it up to bacterial invasion. So we have oil just to keep our skin from, getting dried out and cracked like that. Oh, let's see. We'll talk more about the hair. There's some of the blood vessels in the dermis, and of course there's some up here, right up on the subpapillary. There's the sweat gland, and you can see the pores there. Now, this guy is an eccrine sweat gland, This is most of our sweat glands, and this guy is for heat regulation, thermoregulation. Now on that hair shaft right there, you see this little muscle. This muscle is very commonly misspelled in the lab, and I could see your point, but nonetheless, we got to spell it the way they say, the arrector pili. So what happens is when the sympathetic nervous system gets engaged, that muscle is going to contract and it's going to pull the hair straight up. Everybody's seen a cat, you know, when it's frightened or whatever, put its hair up to look bigger. Well, we do that too, and when we pull on it that way, we actually pull down the skin around the hair shaft, and so it looks like a bump, and that's a goose bump. That's what they are. It's just the arrector pili making our hair stand on end. And any kind of strong emotion, you know, fear, whatever that activates the sympathetic nervous system, we'll keep that. Okay, there's our Pacinian corpuscle. It's deep in the dermis, so in order to activate that, and you got to press hard. Unlike the Merkel's disc, which are up here at the junction between the dermis and the epidermis. Guys, I think we've just about exhausted everything on this one. Let's move on. I'm keeping track of time. This is not a long slideshow, but I will cut it off at about 30 minutes or halfway through, whichever comes first. Okay. Epidermis. We talked about stratified squamous epithelium. We talked about that some of it is keratinized and others non-keratinized. The skin is keratinized. What is keratin? Keratin is a protein, and it's what your fingernails are made out of. It's what your hair is made out of. The one that's in the skin is just a little bit harder than that. So we produce this keratin in the skin cells, and eventually, you remember how, well, we haven't talked about that, but in any case, what happens is the skin cells, as they go further and further away from the bottom, they're going to die because there's no oxygen and no food reaching them, because you can only diffuse like 10 cells layers high, and after that, there's nothing left. So that's fine, because basically what these guys at the very tip top of your skin, they are dead cells full of keratin. They're bags of keratin. They're there to protect you from abrasions and bumps. And of course they slow off very easily. So the keratinocytes are the ones that produce the keratin, which can be most of the cells. The melanocytes, lower down, those are the guys that make the melanin pigment. The melanin pigment is going to cover the bottom layer of cells because that's the layer that's dividing. And if the ultraviolet radiation gets in there, it can damage the DNA, and that's where we get our skin cancers. The dendritic cell, also called a Langerhans, it's really just a macrophage that's specialized, that hangs out there to alert the immune system and, you know, sound the alarm that we've got bad guys in the area. We already talked about the Merkel cells. Okay, let me make sure I move myself. Okay, guys, there are 4 layers in skin, except the skin on your palms and on the soles of your feet. I'm going to move over here so I get out of the way. Oh, that didn't help. Which has 5 layers. So let's go through this. The very bottom layer, this is the layer that is next to the dermis, is the base layer, and they call it the stratum basale. 1 cell layer thick. Its only job is to divide. 1 cell stays, 1 cell starts its migration toward the top. The stratum spinosum is the next layer up. These guys are going to be actively producing the keratin, the pre-keratin filaments, but they're working on it. The reason they call them spinosum is when they put them under a microscope and they get dehydrated, the cells kind of shrink in, but they're still connected to the other cells, so it looks kind of spiny, spiky. But in real life, they're not like that. They are connected together with desmosomes, so these guys kind of stick together. The granulosum is the next layer up. 3 to 5 layers. They're going to be flattening. The cells are dying. They're full of the lamellar granules, the lipids, the fat that's going to repel water, and then the keratin fibers. And finally, you got the topmost layer, which is also the thickest, and it's just dead cells. And they're flattened, and they're filled with keratin, and in between, you've got those lamellar granules, glycolipids that repel water. So that's now, if you got skin that's thick, between the granulosum and the corneum, you have an extra layer called the stratum lucidum, but you only find that on the palms of the hands and on the soles of the feet, because they're the areas that are going to be subject to the most abrasion. Okay. There's a dendritic cell. There's the Merkel cell. The melanocyte right there. And again, the most critical area to protect from ultraviolet radiation from the sun is going to be our dividing cells, because they divide a lot, and if they get damaged, you can have some problems. Stratum basal, deepest, single row, 25 to 45 days, about a month on an average. It's also called stratum germinativum, but don't worry about that. Just call them stratum basal. Okay, stratum spinosum. They're attached by those desmosomes, and they're starting to make the keratin precursors. And they've got a lot of the melanin granules, because they're the area where you put that sunshade over the stratum basal. Also have dendritic cells there, because if something gets in through the skin, we want to know about it as soon as possible so we can respond and not let it get out of control. Granulosum, more of the lamellar granules, the keratohyalin, the keratin precursors. Whoops, sorry, did that. Okay. The lucidum, thin, transparent. It's right on top of the granulosum. And again, they're flat, dead cells. It's really like an addition to the corneum. And then finally, the corneum. It's the barrier. It's dead, and it's going to flake off, because we're going to flake off the entire layer of epidermis about once every 30 days. It's how long it takes to go from the basal to the top of the corneum, and then we shed, which is a good thing. Okay, epidermal cell types. Let me go back over here, guys. Keratinocytes produce keratin. How about that? Melanocytes produce melanin. It accumulates in these little vesicles called melanosomes, and they get around the nuclei of the keratin in the side that faces the sun, and again, they're protecting basically the stratum basal. And we already talked about the dendritic cells. Dermis, connective tissue, which we've already talked about in the tissue chapter. Fibroblast, they make the fibers. The macrophages, they're there for bad guys. The mast cells are the guys that start the inflammatory process with histamine and some other chemicals. Some white blood cells, but again, don't really hang out there unless there's a problem. Now, the epidermis, being epithelial tissue, has no blood supply. The dermis, on the other hand, has a great blood supply, nerve fibers, lymphatic vessels, the lymph nodes. have the glands that come from the epidermis, not directly. It's more like they have a common ancestor. The sweat glands and the oil glands and the hair follicles. The cells, fibroblasts, mast cells, white blood cells. We've already talked about that. And the papillary and the reticular layer. And again, this is better. It's not quite so busy. It's got, but you can see, okay, that dark line following our papilla there, that is the stratum basale. And the stratum spinosum is right up above it, the granulosum. And you can see here, there's a very distinct difference. This is not what you're going to see on a microscope slide, but on the picture, that's the stratum corneum. Dead, flat cells full of keratin. Papillary layer, areolar loose connective tissue. And we'll move over here. And we know areolar has collagen and elastic tissue and even reticular fibers. I said elastic tissue, I meant elastic fibers. Now, in the dermis and the papillary layer, that's where we have these ridges. Those ridges are kind of push on the epidermis above it, and that's our fingerprints. What are they for? Well, they give a little bit of friction, so that helps you to grip things with your fingertips better. If your fingertips were entirely smooth, you know, it could, I don't know if you've ever used a pair of pliers that were smooth versus one that had the serrations, the jaws on it. It makes a big difference. No one has the same fingerprints, as far as we know. Not been found yet. Maybe they will, but so far, no. Now, some folks have been known to file off their fingerprints in order to escape justice. Fingerprints will come back. You can't file them off permanently. If you want to do away with fingerprints, you're going to be sanding your fingers a lot. That sounds kind of painful to me, but I don't know. Okay, the dermal papilla. Thick skin, the dermal papilla lies on top of dermal ridges, which form the epidermal, and we already talked about that. In those dermal papilla, in other words, the papilla that belong to the dermis and not the epidermis, we got those loops of capillary. That's where the blood vessels come up, so that they're closer to the epidermis. That's where the Meissners are, right at the border. You get free nerve endings, and those are pain receptors, heat and cold receptors. Small blood vessels, well, we already talked about that. This function is to let it come back up. I have no idea why we got those cleavage lines again. I'm not going to talk about them again. They're just, there they are. Now, the reticular layer is dense, irregular connective tissue. We know it's the majority of the dermis. Collagen fibers that are oriented in every possible direction makes it very strong. There's some elastic fibers so that when you pull your skin up, it snaps back. The glands, erector pili muscle, flexure lines, where your skin folds. The easiest one to see is right there between your arm and your forearm. You've got a line there because your fold. We got lines right there on our fingers where we can flex our fingers downward. The cleavage lines are just the direction that the collagen fibers run. That's probably why I put that back there. And we already talked about that part. Hypodermis, again, not really the bottom layer, but it's just a fatty layer. Insulates, protects, kind of cushions. It's the connection between the dermis and the underlying muscle and bones. Sometimes, and we already talked about superficial fascia or subcutaneous tissue or layer. Skin color. Skin color, depending, is there's there's only really two pigments, but we call hemoglobin. Melanin is a dark pigment, so people who have moles or nevus, that's melanin. That's a localized congregation of melanin. Can be yellow to reddish brown to black, and people whose ancestors were in tropical regions that were subjected to heavy doses of ultraviolet radiation developed this to protect themselves from skin cancers and dying. Again, it's the same melanocytes, and they just form shields. Freckles are also that. Now, carotene, yeah, it sounds like carrot. That's because it gives us a yellowish orange, and a lot of times you can see that on the palms or the soles of the feet. Now, people who are from the frozen north, like me, from Scotland, where a blazing hot day is 70 degrees in the middle of the summer, don't have a lot of melanin accumulated in their skin because it was not necessary. You don't get that much sunshine. The reason that they're saying that European folks have pinkish skin is because of the hemoglobin in our blood vessels is kind of a red color. So it's not really a pigment. It's really more a lack of a pigment, but it is what it is. That is basically the only difference. I mean, there are some other superficial genetic differences between the different groups of people in the world, but that's it. Now, there is a certain fungus that when it attaches to people will totally do away with melanin. So if you get that and you're European and you get tanned, that area where the fungus is not going to tan. If your ancestry was from Africa, then it's going to do away with that melanin coat, and your hand's going to look exactly like this, says the guy with the experience who's seen it. So that kind of gives you an idea of how little difference there is between people. It's insignificant. It's only good for genetic diseases that you have to give different drugs sometimes because different people have different enzymes. And that's really more of an inheritance thing than it is anything else. But anyway, I'm trying not to get into philosophy, guys. I'm here to teach you about A&P. The derivatives of the skin, the hair and the hair follicles, the nails, sweat glands, and the oil glands, the sebaceous glands. This would probably be a good place to stop. I know I'm not quite halfway there, but I am 30 minutes in. Before we go on to these guys, we'll do that in the second video, and I think that'll be better. All right, guys, I appreciate your attention, and I will see you in the next video.